Hello students, this is our video for the second half of lesson 15. First half of lesson 15.5. Second half is tomorrow. 15.5a starts on page 286 and is continuing to look at the volume of rectangular prisms, and then we'll also actually be looking at liquids and how to measure their volume. The first thing to know is to make sure that we're using the right vocabulary when describing the different dimensions of cubes and rectangular prisms. We've been talking about width, length, depth, height. And part of the reason we've been using those somewhat interchangeably is because if you shift something, the height could potentially change. If I rotated this shape, then a different dimension on here might be considered the height. When I'm looking at any kind of rectangular prism or cube or any of these other shapes, the height is how high the thing is off the ground. The length is from left to right, how long that thing. And the width is how deep that things go. How wide is that actual piece? Is it very thin or does it have a large width? Is it long or is it really narrow? Is it high or is it low to the ground? So just to make sure we're familiar with that. And again, these are not locked in. As I rotate this shape, something else could be the height. Something else could be the length. The length is not always the longest side, and the width is not always the shortest. It depends on how the viewer is looking at that shape. So looking at these, the length is kind of from left to right, how long it is, would be 6 centimeters. The width of this one is 4 centimeters, and the height is 5 centimeters. Now looking at this rectangular prism, the length, how long it is 3 inches. And you can actually see the width is also going to be 3 inches. So sometimes the width and length may be the same, and in a cube they'd all be the same. But the height is different. The height is 9 inches. All right, these are good terms to know as we talk more specifically about calculating the volume. So that's why we open by looking at that. Now let's look at the volume. This actually ties in a little bit to the question that Declan asked yesterday during our Zoom class. To find the volume of this rectangular prism, I could actually just count how many little squares there actually are. I can see there's 2 layers, and each layer is 1, 2, 3, 4, 5. The length is 5, and the width is 1, 2, 3, 4. 4. Or if I count that up, I could see that each layer here is equal to 20 cubes. And how many layers are there? There are 2. So there's a bottom one down here that is also 20. And 20 plus 20 would give me 40 centimeters. Do you remember how I write this? 40 centimeters cubed, because I'm looking at 3 different dimensions. It's a 3D shaped, so it's cubed. Or you can think about the little unit cubes that make this up. Now what I also said on Zoom yesterday is you may not want to count 40 little cubes to know how big it is, which is why we don't always draw the unit cubes. This shape, or this solid, would be the same size as this one here. Except instead of saying that each cube is 1 centimeter, I'm going to say the overall height is 2 centimeters. The overall width, or length, excuse me, is 5 centimeters, or 5 cubes. And the width is 4 centimeters. And if I multiply all 3 of those together, 2 centimeters times 5 centimeters times 4 centimeters, or 10 centimeters squared, times 4 centimeters is equal to 40 centimeters cubed. You can see I get the same answer. Sometimes it may be a little bit quicker to go this way. Sometimes this way may be quicker. But it's important to know both methods, especially this one. Here's an example of one you would not want to count up. 14 by 14 by 14. Those are going to be some big numbers. 14 centimeters times 14 centimeters would get you 140 plus 28, 56, 296 centimeters squared, but then times 14 again, which, to save us time, would be 2,744 centimeters cubed. So I ask again, Declan, would you like to count all of those cubes? Probably not. Similarly with this one, 15 times 14 times 9. Does the order matter here? No, it does not. Remember, in addition and multiplication, you can do it in any order and you'll typically get the same answer. Sometimes some are easier. Again, for the sake of time, so you don't watch me just doing some math. Once you multiply all those together, you get 10,648 meters cubed. Never forget about that cube. That's very important. Otherwise, it seems like there's just a line that's that long. The cubed is what tells me this is a 3D shape. So again, kind of the point of this one is saying you're not going to count 10,648 specific unit cubes. So multiplying the length, the width, and the height is important to know in finding volume. Speaking of volume, remember way back at the start of this lesson we talked about liters. That's one of the more common ways to talk about volume when we're considering liquids. Maybe we'll go buy 2 liters of soda or something like that. It's useful to know the conversion, or how many liters is equal to how many centimeters, let's say. If this is 1 liter of, let's say, your favorite blue drink, maybe, I don't know, blueberry soda is a thing, blueberry soda. You've got 1 liter of it. Remember, 1 liter is equal to 1,000 milliliters. So 1 liter is quite a bit bigger than the milliliters. These are smaller. If you poured 1 liter into a 10 by 10 by 10 centimeter cube, you would fill the entire thing to its maximum capacity, which is a word I'm pretty sure most of you have heard, but just to make sure you're familiar with it in math class, capacity is the most that something is able to hold. So maybe if you've seen a hotel or a museum that says we're at maximum capacity, they can no longer hold anyone else. Or 1 liter in this cube would be at maximum capacity, which means 1 liter is equal to 1,000 milliliters, which is equal to 10 times 10 times 10 is 1,000 centimeters cubed, is equal to 1,000 centimeters cubed. That's an important conversion to know. And also from this, but another one, if 1,000 milliliters is equal to 1,000 centimeters cubed, what's 1 milliliter equal to? Well, 1 milliliter would just be 1 centimeter cubed. So that's somewhat of a simple conversion. So at the end of this section, and the last thing we'll do for today before you start your homework, is just converting milliliters or liters to centimeters cubed, or the other way around. So 850 milliliters would be how many centimeters cubed? Remember that 1 milliliter is equal to 1 centimeter cubed. So this would actually simply be 850 centimeters cubed. Simple enough. What about 2 liters to centimeters cubed? Well, each of those liters is worth 1,000 centimeters cubed, so that would be 2,000 centimeters cubed. And then 12 liters and 5 milliliters, the 12 liters would be 12,000 centimeters cubed, and just those 5 little milliliters would be 5 at the end, so 12,005. All right, and then going down to centimeters cubed, to converting to milliliters or liters. 530 is less than 1,000, so we're just going to stick with milliliters here. 530 milliliters cubed. 7,005 centimeters cubed would be 7,000 milliliters cubed, but I can change 7,000 of those milliliters into 7 liters. So it'd be 7 liters with 5 milliliters left over. And then finally, 15,060 centimeters cubed would be 15 liters and 60 milliliters left. Okay? So some of this will feel pretty familiar to what you were doing yesterday, actually, but some of it may feel quite new. The only pages you're working on today are 181 to 184. So make sure to do those problems, check your homework, let me know how you did. And then tomorrow we will finish up this lesson, this chapter, this year. Thanks, guys.